Okay, now let's discuss univariate analysis. Let's see how we can pull a significant amount of insights from one column of data. That's univariate analysis. And so univariate analysis is really going to take you down two paths. One, we want to look at the distribution of data inside a single column, standard deviation, the range of data, the interquartile range. And we also want to look at the central tendency. In univariate analysis, it applies to both numeric, both continuous and discrete data, as well as quantitative data, both ordinal and categorical. I meant qualitative data, sorry. Both ordinal and categorical data. So univariate analysis. A lot of times what we will use is we'll use, density functions, histograms, box plots, count plots, violin plots. We'll use those types of things to visualize a univariate analysis. But again, we just want to see how much information we can pull from a single column of data. So let me go ahead and demonstrate this. Let me share my screen. Okay. And what I'm going to do is I'm going to, let me maximize my screen here. Okay, so what I'm going to do is I'm going to start by getting the data analysis template. So if you go to this link here, github.com/finago/CTS2451, you go to this link right here, you should be able to pause the video, go to that link. There's two things I want to download. One, I want to download the Data Analytics Excel template, and this will help you with your univariate analysis. And I also want you to download CompassScores.csv. That's a data file. So we'll start by downloading Data Analytics Excel template. So click on it. There's a download button over here. Click on download. All right, that'll download the Data Analytics Excel template. Now I'm going to go back. I'm just going to click on CTS2451 inside of GitHub. And then I'm going to download the Compass Scores, compass-scores.csv. Click on it. When you go to download now, because it's a CSV, it's just going to pull the data up in the browser. Okay, I'll explain what this data is in a second. But once this comes up, the ask is for you to right-click anywhere in here and do a save as. So I'm going to save as compass-scores.csv. Compass-scores.csv. Okay, so these are gone. Let me open up the two files. First one is compass-scores.csv. You go to downloads. Here we are, compass-scores.csv. And we want this to open up in Microsoft Excel. Okay. These are my Compass scores. And then I want you to open up your Data Analytics Excel template in Microsoft Excel. Give this a second to come up. And now we have the enable editing here. Let me open both of these side by side so you can see what we're going to do. Okay. So in the Data Analytics Excel template, go to Descriptive Statistics, and this will all make sense very shortly. Click on the Descriptive Statistics tab, and I want you to click on the letter A, hold down on the mouse, and drag over until you get to column H. So I want columns A through H selected. A through H selected. Then I just want you to right click and copy, and then go over here to compass-scores. I'll expand this now. Let's open a new sheet. Right click in here at A1, let's say, and just do a regular paste. Don't get fancy and do any other kind of paste. Just do a regular paste. And what will happen is that this will copy in all of the equations and everything here. Don't delete any columns, don't do anything. Just paste it in, and you'll have one sheet, one workbook rather, that has compass scores in one tab and sheet 1 in the other tab with what you just copied in. So what I'm going to do is I'm going to rename sheet 1. I'm going to rename this to Univariate Analysis. Univariate Analysis. Almost to the point where we can start to pull value from this data that we have here. So our next step is to go to compass scores. And what I want you to do is I want you to pick a numeric column. So we can either do, here, let's do age. Age is a numeric column. So I'm going to select H for the age column. I'm going to right click on age. Copy age. This is from the compass scores data. And then I'm going to go to univariate analysis. Select column A, the entire column. And then I'm going to right click and I'm just going to paste. Again, don't get fancy, just do a paste. And if you just do a paste, what I want to do is I want to count and see how many values I pasted over here. So if I scroll down towards the bottom, it looks like I have, 11,758. 11,758. 11,758. Now let's go back to the top. I'm just going to click on D1 here, and you can see it's expecting A to go from A2 here to A170, but we want it to go to A 11,758 because that is the depth of our data in that column. So what I want you to do, let me just click over here. I want you to do a find and select. I want you to do a replace. And I want you to replace A170 because right now, column A was going to 170. So A170, I want you to replace that with A11758. In this data set, we have 11,700 and technically 57 records, but it goes down to 11,758 because we have a header. And then do a replace all. And when you do a replace all, you should see 24 replacements. Click OK. And now you're ready to, let's close this. Now you're ready to pull some univariate insights from your data. I can start with things like the count. I can say for age, I have 11,757 samples. But these are the insights I can start to pull. Let me just start to jot some of them down over here. I can say the average age of, let me just say someone in this data set is 35, because I can see that right here. I'll tell you what this data set is in a second. But first, I just want to show you how you can take any data set and pull value from a single column. This is a univariate analysis. I can say that 50%, or another insight, half of the people in this data set is below the age of 32. And I can say the most common age of someone in this data set is 26. 26 is the most common age of someone in this data set. So let's go back for a second. These are the univariate insights. In fact, I'm going to change this to say univariate insights. Let's go back to these compass scores for a second. What this is right here, this data set, this is a data set that came from the Broward County Sheriff's Office. Broward County Sheriff's Office. And what this data does is it shows everybody that was arrested during, I think, 2013 to 2015, somewhere around there. It shows everybody that was arrested. They're in, using their parlance here, the sex, the date of birth, their age category. Are they under 25? Are they between 25 and 45? Or are they older than 45? Their age category. Their race, if they had any felonies as a juvenile. What they did was they said, hey, everybody will be assigned a score of between 1 and 10. 1, 2, and 3 means that you're a low-risk arrestee. That means that if we release you, if you are released from jail, there's a low risk that you would reoffend, called your recidivism. 1, 2, and 3. If your score is 4, 5, and 6, that means you're a medium risk. And if your score is 7 through 10, that means you're a high risk that if you're released from jail, that you will commit another crime if you're released from jail. That's called your decile score. This is one of the most important features in this data set. And this data here, it is reflected here in what is called the score text. In the score text, they said 1, 2, if your score is 1, 2, or 3, 1, 2, 3, or 4, I'm sorry, you're low. 5, 6, and 7, you're medium. And 8 through 10, you're high. 8 through 10 is high. Yes, 1, 2, 3, 4 is low, 5, 6, and 7 is medium, and 8 through 10 is high. So that is what this data set is. So you have your decile score, you have whether this person had a juvenile misdemeanor, whether they had any priors, when they were arrested, when they were released from jail, their case number. What's some other ones? Whether they were charged with a felony or a misdemeanor. If it's O for other, that means that it was probably a traffic offense. Y is another very important feature. So remember, we had the decile score. That was a prediction as to whether somebody was a low, medium, or high risk offender. This column Y, it's either yes or no, whether they committed a crime when they were released from jail. It's yes or a no. Yes means it's a 1, and no is a 0. So this will actually show you how good the predictions are, the decile scores are, because it'll show you whether they, in reality, whether they recommitted or they committed a crime or not once they were released. Okay, so if they did commit a crime, you'll see these R features. R means the recidivism case number. Recidivism means that they were in jail, they got out of jail, and they committed another crime within a 2-year window. So this is their recidivism case, the second charge. What that second charge was, whether it was a felony or a misdemeanor. Okay, AH is whether it was a violent recidivism or not. And so if you see an R, that's their reoffense, their recidivism. And if you see a V, that stands for violent, whether they're a risk of violence or not. Okay, and this is their violence decile score. Not their decile score, but their violence decile score. Okay, and that's the violence decal score text. Okay. All right, so that's what this is right here. So this is what this is. People that were arrested in Broward County and features around the people that were arrested in Broward County. So if I go back to univariate analysis, if I look at my insights are telling me the average age of someone arrested in Broward County is 35 years old. Half of the people that are arrested in Broward County during that time frame anyway, they were above the age of 32, and the other half was below the age of 32. And the most common age of someone in the data, the most common age of someone being arrested in Broward County is 26. And then what I can do is I can start to look at things like the range. People were arrested between 18 years old and 96. So there's a 78 year range. I bet you a lot of that will be outliers. I can look at the min and max to get that. There's my interquartile range. I can look at my data here and I can say that 10% out of everybody that was arrested in Broward County during that time frame, 10% were 22 years of age or below. And since I know it starts at 18, I can say between 18 and 22 years old, 10%. I can say that out of everybody that was arrested in Broward County during that time frame, 10% were 53 years old or higher. 53 years old or higher. And because this is in the second quartile here, I can say half of the people were above 32 and half of the people arrested were below 32. That's the 50% mark. These are all insights that I can pull from this one single column of data. This one single column of data. I can even go in here and say, this is my mean, and my standard deviation is 12. And if central limit theorem holds up, based on central limit theorem, I could say at 35, I can do 35 plus or minus 12, 35 plus or minus 12 contains approximately 70% of all of my values. So for the age, about 70% of all arrests were of people between 47 and 23. This is what univariate analysis looks like. This is what univariate analysis looks like. And this is just with the age column. This is how you get to know your data. And if I said, okay, this is age, if I went back to compass scores and said, you know what, let me look at, instead of compass scores, let me look at the decile score. I'm just getting one column of data. I'm going to copy that one column of data over here to univariate analysis. And let me just paste this in here. When I paste this in here, I have the same, I don't have any spaces or empties. So I can look at this now and I can say the average score of an arrestee is 4.3. That's the average decile score. The average decile score someone arrested is 4.3. Okay. If I go up or down 2.8, there's my mean, up or down 2.8, about 3 more or less. I'll see that the average score is about 1.5 maybe. I'm sorry, 70% of the values are between 1.5 and maybe 7. 70% of the values are between there. Okay. I have some that are a -1, so that means I need to clear that from my data set. I need to clear these from my data, the -1. I'll show you how to do that in a second. I can see that 10% of everybody that is arrested, 10% of everybody that's arrested has a decal score of 2 or below. And it's only 10% and higher that have a decal score of 9 or above. Actually, that's the first quartile. So the 10th decal, this makes sense, right? These are deciles, the scores are between 1 and 10, so the percentiles should be between 1 and 10. So these are the quartile scores right here. So these are all the insights that we can pull. And we can do this for literally any numeric column of interest that we have here. Okay. All right, so I think I'm going to, here I'll do one more. I'll look at priors. This is priors count, whether they have prior arrests. And I'm sure, again, that there are outliers here. Well, let me paste this right here. Okay. And these are the priors. These are the priors that people arrested, prior arrests that people in Broward County had. So the average person arrested in Broward County had 3 prior arrests. Okay. Some people had 0 prior arrests. Some people had 43. I don't know who had 43 prior arrests, but that's a lot of prior arrests. Okay, my interquartile range, my mean, the mode. Look at this. Most people arrested during this time frame had no prior arrests. That's what the mode is telling you. So just getting comfortable with what this data is telling you. This is just in a single column here. This is a single univariate analysis. That's what this is telling you here. Let me go back to compass scores for a second here. And here's the other thing that I want you to do for univariate analysis. What I'm going to ask you to do is to go back to compass scores. I'm going to ask you to select all of the columns here in compass scores. Okay, it looks like in mine it's going to go out to AU. And then from here, I'm going to ask you to insert a pivot table. Insert a pivot table. So the range will be what you selected, and you want this to go into a new worksheet. And click on OK. So here it is on sheet 2. I like mine to be organized, so I'm going to move my sheet 2 over here at the bottom. And I'm going to rename this sheet 2 to pivot univariate analysis. Okay, so if I pivot my univariate analysis, what I can do is I can then go in, let me see, I was just looking at, what I like about pivot tables is that I can do a univariate analysis on categorical data and numerical data as well. So I'm just going to say rows or prior count. No, I'm just going to do values as prior count. And I'll put the rows over here as well for priors count. So what I can do now for my univariate analysis, this is the sum of priors count. So I'm going to go over here now, and I'm going to hit the down arrow and scroll down to the bottom. I'm going to get rid of all the blanks over here. So univariate analysis, because I'm only analyzing one column of data. Okay. Only one column of data. Okay. And so I can see out of everybody that was arrested, there was a total of 36,237 prior arrests of people that were arrested during this time frame here. This is the sum. But the sum is not going to really tell you a lot. What you really want is you want to go over here to values. You want to go to value field settings. And you're going to want the count of priors count. So what this is telling me is that out of everybody arrested during this time frame, 4,184 people had no prior arrests. 2,199 had one prior arrest. 1,281 had two prior arrests, etc. And you can see a definitive linear trend. It's almost perfectly linear, actually, when you just look at priors count. One column of data. Look at all the information that I can pull from this. And in fact, I'm just looking at priors count. There's a lot more columns that we can analyze with just one. Let me go over here and go to Insert, Recommended Charts, and I'm going to do a clustered column chart. I'll accept the default, just go OK. And you can see this lines up almost perfectly. You can see what this is telling me is that most people arrested have no priors. Most people arrested only, have a couple of priors, and then it starts to drop off pretty quickly. And, once you start getting out here, we start looking at a bunch of outliers out here, a lot of outliers out here, okay? Okay, so you can do this with any column. This is universal. I randomly picked one data set, and I just interrogated one column in one data set. You would do this continuously. You would do this continuously, except you wouldn't just look at one or two columns like I did. You would get several columns that you're interested in, and you would pull as many insights as you could from those columns one at a time. So what I just showed you is univariate analysis. I'm going to stop here, and then we'll take a look at bivariate analysis and multivariate analysis. Thank you very much.